So welcome students. So in this question, given that you have a 3-digit number ABC and this 3-digit number is divisible by 9, and you're given that the first hundredths digit is odd, units digit is even, and B and C are non-zeros. So if these three conditions are valid, how many possible 3-digit numbers are there? So let us try to count the numbers systematically. So you have three numbers. It is given that the number is divisible by 9. That is, the sum of the digits has to be divisible by 9. So if you take these three numbers, the sum of these have to be divisible by 9. That's the divisibility rule for 9. So if a plus b plus c is equal to 9, every number, each of these numbers can go from 0 to 9. So the maximum number is 9. So a plus b plus c cannot be 100. So these are three numbers which are single digited numbers. The sum can be either 9 or 18 or 27, but 27 is also not possible because this sum will become 27 if all the three are 9s. But it's given that c is even. C is not 9. So you have only two options. The sum of the numbers is either 9 or 18. Next, the first digit is odd. So let us start our analysis. So if the first digit is odd, that is, the first digit can be 1, 3, 5 or 9. So let us take the first digit as 1. So let us try to find the cases. So if the first digit is 1, what can be the next digits? So if the first digit is 1, the last digit has to be even. So the last digit has to be even and not equal to 0. So the last digit can start with 2. So the last digit can be 2. So if the last digit is 2, so 1, 2. The last digit can be 4. The last digit can be 6. The last digit can be 8. So if the first digit is 1, the last digit is 2, this digit has to be equal to 6 because the sum has to be 9. The sum cannot go to 18. Say 1 and 4, if this is 1 and 4, the next digit should be 4. 1, 4, 4. And 1 and 6, 7. So the next digit has to be 2 such that the sum is 9. 1, 8, 1, 8. That is, the sum is 9 already. So the middle digit, which is B, can either be 0 or 9, but 0 is not valid because B is non-zero and this has to be equal to 9. So if the first digit is 1, we have 4 different 3-digit numbers that are possible. So next case, let us go to first digit 3. So if the first digit is 3, so how many different 3-digit numbers can be formed? So if the first digit is 3, so the last digit has to be either 2, 4, 6, 8. Either 2, 4, 6, 8. Now if the first digit is 3 and the last digit is 2, so the sum is 5. So the middle number has to be equal to 4. The sum is 7. The middle number has to be equal to 2. The sum is 9. Middle number cannot be 0. Sum has to be 9. So the sum is 11 already. So the sum has to be 18. So the number has to be 7. So you have 4 options again. So let us take the case 3. Let the first digit be 5. Let the first digit be 5. So the last digit can be either 2, 4, 6, 8, one of these. Sorry, you have only one digit in between. So talking about a 3-digit number. So now the sum is 7. The sum is 7. So the total sum has to be either 9 or 18. It cannot be 18 because, so this has to be 2. So 5 and 4, the sum is 9. So either 0 or, it has to be either 0 or 9. 0 is not possible. So it has to be 9. The sum is already 11. So it has to be 7. Sum is already 13. So this has to be 5. So you have again 4 numbers. So finally, if you take the case 4, So the first digit can be 7, the odd number. The last digit can be 2, 4, 6, 8, one of this. So the sum is 9, so it has to be equal to 9. The sum is 11, it has to be equal to 7. The sum is 13, so the middle digit has to be equal to 5. Sum is 15, the middle digit has to be equal to 3. So there are 4 more options. So you have a total of 16 different options. Have a total of 16 different 3-digit numbers which satisfy all the conditions. So again, if you are given that A, B, C are 3 different numbers, then you won't get all the 16. So if A, B, C are all different, you cannot have this. This option will get eliminated. So in 3, 4, 2, 3, 2, 4, 3, 9, 6. So in this there is no elimination. So this has to be eliminated. This has to be eliminated. And 7, 9, 2, this has to be eliminated. So if I want 3-digit numbers where all the digits are different, so you have only 12 options. If repetition is allowed, you have a total of 16 options, depending on 16 or 12, depending on whether you want all different or if repetition is allowed. Thank you.